All right, we're going to take a look at the trigonometry review. Now, we discussed this stuff in class, so I'm not really going to go over the discussion questions, but we're just going to take a look at the other problems to make sure you understand what's going on, especially the trig ones that will help you out on the ACT. So, first one's to measure the angle. Okay, remember, the side right here on the right is always called our initial side. Then, if we go down, we're making a negative angle. If we go up, we're making a positive angle. Okay? And then the side that we end on is called our terminal side. Okay? And a full circle is 360 degrees. So, let's do these. So this one goes down and clear around, so almost 360. Okay? But each quadrant would be 90. So 90, 180, 270, 270 plus 75 would give us 345 degrees and a negative because we went the negative way. Number 3, we're going down. We don't make it to 90, so I'd go 90 minus 65 to get 25 for our degrees. Because we went negative, it's negative 25. For 4, this one going positive, and if we went the whole way, that would be 180, so 180 minus 100 would give us positive 80 degrees. And finally, with number 5, we go around, so another negative 65, that's pretty close to the 75, so we go 90, 180, 270, 270, and 65 would be negative 335 degrees. So that's finding the angles. Now, how do we draw the angles? Same idea. We always start with our initial angle right here. That's like 0 degrees. To go to 75, we're not going to quite go to 90, so it looks something like that. For 250, we'd start right here, and we go 90, 180, 270 is down here, so about right there. Would probably be 250 degrees. Okay, 70, initial angle, terminal angle about there, 70 degrees. 335, initial angle, 90, 180, 270, 335, be pretty close to 360, so something close to that would be 335. Okay? Now, radians and degrees. If we're swapping between the two, we're going with this concept that if we go around, a radian, remember, is that radius, it's the distance in the arc length. That same distance as the radius. So when we go through, and if we would measure it out, we would end up with, that wasn't very good, with 3 radians plus a little section. Okay, so we end up with about 3.14 radians, or what we call pi. So half a circle, 180 degrees, is pi. So those two together, okay, help us with the conversion of radians to degrees. So if I have degrees, we times by pi over 180 to get it in radians. If we have radians, to get it into degrees, we times by 180 over pi. Okay? Now the way we think through it is like this. So I'd go 210 times pi divided by 180. You could type it like that in the calculator, and you get about 3.665. Okay, that technically is a radian. So the problem is we usually like them to look more like this without figuring the pi into them. So if I factor, 210 is like 30 times 7, and 180 is like 30 times 6. So the 30s cancel, and I'd be left with 7 pi over 6. Okay, this and this are the same thing, but we prefer that other one, and we'll see that later on when we go over this unit. Okay, so number 12, we get 105 pi times 180. 105 is like 15 times 7. 180 is 15 times 12. So the 15s cancel, and we are left with 7 pi over 12, which is the same as 14, which, if we did it backwards, Okay, 7 pi over 12 times 180 over pi. The pi's would cancel. 180 is like 12 times 15, so the 12s would cancel. We'd be left times 15. 7 times 15, which is 105 degrees. Okay, number 3 again, the pi's cancel. 180 divided by 6 gives us 30 degrees. Okay? Now, sine, cosine, and tangent. Okay, hopefully you remember the acronym Sohcahtoa. Remember, that stands for the sine of our angle, which we write as theta, equals the opposite side over the hypotenuse. The cosine of our angle equals the adjacent over the hypotenuse. And the tangent of our angle equals the opposite over the adjacent. Okay, thinking in terms of a right triangle, where depending on where our angle is, the side it opens up to is opposite, the side it touches is the adjacent, and the hypotenuse is across the 90-degree angle. Okay, so this works with right triangles, and this is the stuff that you'll see on the ACT. Okay, now remember that these trig functions, they connect an angle with two sides. So sine connects an angle with the opposite and the hypotenuse, cosine with the adjacent and the hypotenuse, tangent with the opposite and the adjacent. So together we cover any of those. Now those are three variables, essentially. So in order to make it work, we need at least two of the three. Now that can be an angle and a side, or two sides, or anything like that. So let's start with the simple stuff, just making the ratio. So tangent of theta. Tangent, opposite over adjacent. Theta's right there. So the opposite is 6. The adjacent is 9, because 3 square roots of 13 is the hypotenuse. We can reduce that to 2/3, I mean. So the tangent of theta in this triangle is 2/3. The sine is opposite over hypotenuse. So our angle's right here. The opposite is 7, hypotenuse 25. Can't reduce it, so 7 over 25. Okay, cosine. Cosine is adjacent over hypotenuse. Adjacent would be 6, hypotenuse is 10. 6 over 10, which we could reduce by 2s to 3/5. And finally, the tangent. Again, tangent is opposite over adjacent, so it would be 3 over 4. Okay? So that's the pretty simple stuff right there. Okay? All right, now, some other trig functions, which are called our reciprocal trig functions, are cosecant, secant, and cotangent. Okay? They connect to sine, cosine, and tangent, but they're the reciprocals. So the sine was the opposite over hypotenuse. Its reciprocal is cosecant, which we write as CSC. So the cosecant is the reciprocal, which is the hypotenuse over the opposite. Okay? So the cosine is adjacent over hypotenuse, and it's connected to the secant, which would be its reciprocal, as hypotenuse over adjacent. So then tangent, which is opposite over adjacent, is the reciprocal with cotangent, which would be adjacent over opposite. So we treat it the same way, just a different fraction. Now, we didn't have a secant here, so let's change this one to a secant of theta. So cosecant, hypotenuse over opposite. Hypotenuse, 17 square roots of 2. The opposite, 17. We reduce that. 17 over 17 is 1. So we just get the square root of 2. Okay. 22, if we did cosecant, would be the hypotenuse over the opposite. But if we do the secant, it would be the hypotenuse over the adjacent, which would be 4. Okay, so it's as simple as that. Now the cotangents, opposite of tangent, so the opposite over adjacent is tangent, so we'd go the adjacent over the opposite. Oh, that's hypotenuse 13. The adjacent would be 12 over the opposite, which would be 5. The adjacent is 8 over the opposite, which is 6, which we could reduce to 4/3. Okay? And that's all we do on those ones. Now, on these next ones, we're still dealing with the trig. So, this time we're going to try to find 1 out of the 3. So as I said, we need 2 things. Okay, and depending on which sides we're dealing with determines whether we use sine, cosine, tangent, or the opposites. Okay, so we have our angle 45. Its opposite side would be 10, and the adjacent would be x. What connects opposite and adjacent? That's tangent. So the tangent of 45 degrees would equal the opposite, 10.2, over the adjacent x. Now, there's 2 ways we could do this. We could say, well, we times by x, giving me x times tangent of 45 degrees equals 10.2. Then we divide by tangent of 45 degrees, because the way you think of tangent of 45 is like a number. Okay, we get x equals 10.2 over the tangent of 45 degrees. However, knowing the reciprocals, if I just flip this to x over 10.2, that would be the cotangent of 45 degrees. Then all I'd have to do is times by 10.2, and I'd get 10.2 times the cotangent of 45 for my answer. Okay, so you can use either one, but now you have to use your calculator. So you get out your calculator, you go to the trig, you type it in how you see it, and get your answer. Making sure that since we're dealing with degrees, that your angles are in degrees. That's kind of the catch. You have to make sure your angles are in the right format. So when we type these in, we end up with 10.2 for our answer. Either way we do it, which makes sense because it's a 45/90, which means this has to be 45 and the legs are the same. So could we have done that without the trig? Yeah, we could have, but it's good practice in the trig. Okay, let's take a look at the next one. 26. So our angle's right here. We've got the opposite side and the hypotenuse. So opposite over hypotenuse is sine. So I'd go the sine of 70 degrees equals the opposite, 9 over the hypotenuse, x. We could also use the cosecant of 70 degrees, because then that would be x over 9. Then you would just times it by 9. So either one works, okay? It doesn't matter which one you do. If you worked through this one, you'd end up getting x equals 9 over the sine of 70 degrees. Okay, so whichever one you choose, you're going to get the same answer, which ends up being this. About 9.577, so 9.6. Okay, 27. Our angle, we've got the adjacent and the hypotenuse, so x over 3, which would be the cosine, because cosine is adjacent over hypotenuse. This one's easy, so we just times it by 3. So 3 times the cosine of 29 degrees gives us about x equals 2.62, so 2.6. Okay, that last one, angle here, we have the opposite and then the hypotenuse. So it would be sine again. So the sine of 60 degrees equals x over 15. Now, this would be a 60, 30, 60, 90. So there's actually a special rule that would work with this one as well, that would get you your answer. Okay, and the short side is half the long side, so that would be 7.5. Now the long leg is the short leg times the square root of 3. So if you typed 7.5 times the square root of 3, you would get the same thing as, if we times by 15 here, we'd get x equals 15 times the sine of 60 degrees. Which is the same thing you get regardless of one of these. So 12.99, so basically 13. You have to round that up to 13. Okay, so there we go with those ones. Now let's take a look at the other page. Okay, so the other page, Pythagorean theorem, right? A squared plus b squared equals c squared. So for these ones, the two legs are a and b, so 9 squared plus 10 squared equals x squared. 9 squared 81, 10 squared 100. We get 181 equals x squared. Now, two ways we can deal with this. We'll take the square root of 181. Okay. Most of the time we're fine just using a calculator, taking that and getting 13.45. However, this wants simplest radical form. In order to do that, we have to factor. Okay, 181 is not an easy one to factor either. So I'm trying some numbers. So far, I'm not finding anything that factors out easily at all. And I think that's as simple as we get on that one. So, on the ACT, will it want it this format or this format? Could have it in either one. Okay, number 3, now let's take a look at number 3. So, this time we want a leg. So we say the x squared plus 5 square roots of 2 squared equals 16 squared. Now, 5 squared roots of 2 squared, we square each one. Square root of 2 squared is 2, 5 squared is 25, so we'd get 50. And 16 squared is 256. So we'd subtract 50, so we'd get 206 equals x squared. Take the square root of that, and we would get, if we typed it into a calculator, about 14.35. However, if we're simplifying that, we could go 206 divided by 2 would be 103. Can we simplify that further? Once again, I think this one kind of eludes. Yeah, we could make it square root of 2 times 103, but that's not going to help us any. Okay, so we just leave it either one of those. Okay, number 4. Okay, we've got the hypotenuse, so I could rewrite it 13 squared minus 8 squared equals x squared, because that's essentially what we're doing. So 13 squared is 169, 8 squared is 64, equals x squared. Simplify that, we get 105 equals x squared. Take the square root of 105. We get about 10.25. Okay, or can we factor it? We could. 105 would be 5 times 21, 21 7 times 3, but is there anything I can pull out? No, so that's my simplest. Okay, number 5, we've got the hypotenuse again, so 12 squared minus a leg, square root of 37 squared equals x squared. 12 squared, 144, square root of 37 squared, it's just 37. Okay, 144 minus 37 gives us 107 equals x squared. Take the square root, which I don't think we can simplify 107 any further, so it's either the square root of 107 or, if we do a decimal, about 10.34. Okay? Alright. Now the last few things. Okay? So, dealing with special right triangles. We learned in class that for a 45, 45, 90, so 45, 45, 90, we have a special rule. The legs are going to be the same, and the hypotenuse is that leg times the square root of 2. Okay, so if we look at 7, 7 square roots of 2, so I know that my legs are both going to be 7. Number 8, 3 square roots of 2, so I know that the y is 3 square root of 2, and I know that x is 3 square roots of 2 times the square root of 2, which those times together and undo the radical, so 3 times 2, or 6. Okay, now let's say we started out with 6. In order to figure out what that would be, we'd have to divide by the square root of 2 on both sides, and you'd end up getting back to this. Okay, now you're going to use these for this part. Okay, you're going to use that same idea of a 45, 45, 90 if the hypotenuse is 1. Okay, so to figure out what the legs would be, you'd set it equal to this, to x square roots of 2. Then you'd divide by the square root of 2. So you'd have x equals. Now, we can't leave it 1 over the square root of 2. Radicals can't stay on the bottom, so we times it by 1. But we set it up so that square root of 2 times square root of 2 is positive 2. Square root of 2 times 1 is square root of 2. So my two legs are square root of 2 over 2. Okay? Then you look up the sine, cosine, tangent, cosecant, secant, and cotangent of that and figure it out. Okay? Using that Sohcahtoa and those reciprocals. Okay? Now, I'm probably going to make a video of this, but I'm not going to post that one until later. So you'll have to try to do this on your own first. Okay? Now, 30, 60, 90. That's another special one. And we found out that's a horrible triangle. So 30, 60, 90. We found out with this one, it's based off the small leg. The small leg is x, the hypotenuse is 2 times x, so twice as big. And the longer side is that side length times the square root of 3. Okay, so if we look at 10, we've got 3 square roots of 3, that's the longer side, which means the shorter side has to be 3, because it's that part, minus the square root of 3. And then the hypotenuse is double that, so it's 2x. 2 times 3, which is 6. For 11, we have the hypotenuse, so we cut that in half for the shorter side. Then we take that and times it by the square root of 3 for the longer side, for those ones. Okay, now on this, we're going to have to do the sine and cosine and tangent for those ones as well. Okay, and we have the rules right there. But remember, we're finding it for 1. If the hypotenuse is 1. So if the hypotenuse is 1, the shorter side is 1/2, and the longer side is 1/2 times the square root of 3. However, we want to simplify that and make it the square root of 3 over 2. So that's really what we want right there, is the square root of 3 over 2. So using that, find the cotangent, tangent, secant, cosecant of the 30 and the 90. Alright, so there we go. And like I said, I'll probably make a video showing you how to do this, but I'm going to wait till after it's due to post that.